Now the next thing it tells us, when you're reading this stuff here, is it says, if I can highlight this, it says column 4 has mixed types. What that means is that when Pandas is reading a CSV file or reading data from anywhere, it tries to guess the type of that column. When it says mixed types, then what it means is that it's unable to figure out what the exact type is, and some would be integers, some would be strings, and it's not a single uniform type, which is not so good for us, because remember, if we want to do analysis, we want to use an NP array kind of structure, which means that we want the data to be of the same type in a particular column. So let's see what the mixed type stuff has to do. What's going on with the mixed types in incident zip. Column 4 is incident zip. That's the one of the mixed types. And the best way to do that is to use this function called unique. What unique does is it pulls out unique values of in a column. So we get this unique stuff here, and we look at it, and we find that there's a nan over here, right? Then we have zips as strings, many zips as strings, right? And let's scroll down further. We find that sometimes in the United States, all zips are 5 digits, but sometimes we find that there's 5 digits followed by a dash followed by a 4-digit number, right? So that's another problem, and this says something because the Postal Service uses these extra 4 digits for more precise identification of locations. So that shows up in some places, I guess, if the person providing the complaint has provided it. Then we have a zip unknown, which is not very helpful. We can scroll down further and we look and see they're all strings here. We see that some strings, though they are strings, some strings have a decimal point in them. So we got to get rid of that because zips don't have decimal points. Then we find that in some places it actually identifies them as as floating point numbers. So we've got a mixed data type coming from this stuff here, that sometimes they are strings, sometimes they're floating point numbers. And you'll notice there's a question mark here that we need to get rid of as well. We scroll further down, and see all the same problems, and then there's a JFK. So we've got a mix of stuff here, and roughly what we are saying is that sometimes a zip is a float, and other times it's an str. Sometimes zip codes that are represented as floats, and especially the ones that start with a 0, are missing the first digit. So we look at this one, for example. This is a 4-digit zip, which is not correct. It's a 5-digit zip, and the reason it's a 4-digit zip is because it's represented as a floating point number, and the 0 that came in front has just vanished because floating point numbers don't have zeros in front. So that's though in our when reading it came in as a string, but somewhere along the way it got entered as a number. The reason for this probably is the way it was entered in the database. Maybe there are multiple entry points. Maybe it's entered on the web, it's entered on an application at the 311 person's desk, it's entered later somewhere, or on a file directly. I don't really know, but there are probably multiple ways in which the data is entered, and we are seeing that this data is messy because of those kind of reasons, and we have to clean up that mess because we have to deal with this data. So we got this. So we have this. We have missing the 0 missing. We have the 4-digit extension. We have somewhere in this stuff, I saw there was a zip code 0. Let's assume it's there. And what the heck is that? A 0 zip code. And then we have nans, and there's a question mark, there's an unknown, there's a JFK, there's some random stuff sitting inside it. We've got to figure out what to do with those as well. So what we need to do is we need to clean the data. Cleaning the data is really a bit of an art. It's a mix of a science and an art, I should say. And the reason it's an art is because while cleaning the data, you want to make sure you don't lose anything of value. It's easy to say, hey, let's just get rid of everything that doesn't make sense. That's problematic. But you might throw out something important at the same time as you're cleaning this stuff out. So it's a bit of an art and a science. So we should keep that in mind as we go through this process here. So the first thing we want to do is, what do we do with this JFK unknown, etc. Ideally, we should probably keep JFK. The reason is that JFK is John F. Kennedy International Airport. It's a well-recognized entity. So we should probably keep it, or maybe give it a dummy zip code or something like that, and keep it in our database. But for simplicity, I'm going to throw it out. Right? But that's one of the considerations that you should think about. So what we're going to do is, anything that we decide is bad, we're going to throw the entire record out. Okay? We're going to say we don't want that record there at all. And that may not be the right thing to do. Maybe we should convert them to nans and keep those records. But for simplicity, we're just going to do that. Keep that in mind, right? then we want to make sure that everything is in the same format, and we're going to convert everything. It's a zip, so we'll convert everything into strings. The idea of converting into strings is that for one thing, it'll keep a 0 in front, though it doesn't matter in our case because New York City doesn't have any zip codes with 0 in the front. But still, just for I guess for the future, we'll just say, all right, zip codes are strings, so we'll keep them as strings. And we're going to decide what to do with the missing values and the nans. So what we're going to do is we're going to take all the bad data and make them nans, and then we're going to make sure that everything is a string and it's a proper integer like 1, 2, 1, 1, 1 or something like that. And then decide what to do with missing values, the nans. We'll make a decision about that, and the decision we're going to make is we'll just throw them out. So, and one other thing we'll do is for now is we'll also drop all zips that are less than 10,000 and greater than 19,999. Okay, the reason for that is that New York City zips are all within this range, and we are going to assume that for now we don't care about any incident that is recorded that is in a zip code that is not in New York City.